Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Haris bin Muhammad.
My name is Nur Aida Zulaiha binti Nazri.
My name is Marissa binti Ahmad Jamal Inasi.
My name is Wadhihah binti Muhammad Rosidi.
My name is Vieraa Amirul Patra bin Izzuddin.
What is related rate? Related rate is known as the rate of change associated with two or more related quantities that are changing over time. The rate of change is using at the second quantity to help us determine how fast or how slow a certain quantity is changing. This generally will involve writing an equation that relates two variables and taking the derivative of the equation with respect to time. Mostly people will use implicit differentiation, but chain rule is become the best solution for this type of problem. The key steps in solving related rates problems. First, identify the variables involved and their relationships. Second, differentiate the equation or relationship with respect to time. Third, substitute the known rates of change and solve for the desired rate.
So now, how do we solve a related rates problems? The problem statement is a 50-foot ladder is resting against the wall. The bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1/4 feet over second. How fast is the top of the ladder moving up the wall 12 seconds after we start pushing? So the first thing to do in this case is to sketch picture that show us what is going on. We have defined the distance of the bottom of the ladder from the wall to be x and the distance of the top of the ladder from the floor to be y. Note as well that these are changing with time, and so we really should write x as a t and y as a t. However, as is often the case with related rates or implicit differentiation problems, we don't write the t part. Just try to remember this is our heads and we proceed with the problem. Next, we need to identify what we know and what we want to find. We know that the rate at which the bottom of the ladder is moving towards the wall. This is x prime equals to -1/4. Note as well that the rate is negative since the distance from the wall, x, is decreasing. We always need to be careful with signs with these problems.
We want to find the rate at which the top of the ladder is moving away from the floor, which is y prime. Note as well that this quantity should be positive since y will be increasing. The third step is to create a relationship between x and y. We can get this by using Pythagorean theorem. The equation we got is x squared plus y squared equals to 15 squared, and it will equal to 225. Now, we're on to the fourth step, and all that we need to do at this point is to differentiate both sides with respect to t. Do note that we shall remember that x and y are really functions of t, and so we'll need to do implicit differentiation. Doing this gives an equation that shows the relationship between the derivatives, which is 2x x prime plus 2y y prime equals to 0.
Next, let's see which the various part of this equation that we know and we need to find. We know x prime and are being asked to determine y prime, so it's okay that we don't know that. However, we still need to determine x and y. Determining x and y is actually fairly simple. We know that initially x equals 10 and the end is being pushed into the wall at a rate of 1/4 feet second, and that we are interested in what has happened after 12 seconds, we know that distance equal rate times time. 1 over 4 times 12 equal to 3. So the end of the ladder has been pushed in 3 feet. So after 12 seconds, we must have x equal 7. Note that we could have computed this one step as follows. As x minus 10 minus 1 over 4 times 12 minus 7.
So, the next step is we should find y after 12 seconds. All that we need to do is reuse the Pythagoras theorem with the values of x that we just found above, which is 7. So, y is equal to square root 225 minus by x square, and we should substitute 7 into x. So, we will get square root 225 minus 49, and we will get square root 176. Next step, we should plug into 1 and solve for y prime. We should just use the formula at the step 4. So, 2 multiplied by 7 multiplied by negative 1 over 4 plus 2 multiplied by square root 176 y prime is equal to 0. And we should solve that. We will get 7 over 4 multiplied by square root 176, and the final answer that we will get is 0.1319 feet per second. Notice that we got the correct sign for y prime. If we got a negative value when we solve that, so we should know that we have a mistake from our equation, and we should go back and solve it. The conclusion is, after studying this subject, we should be able to comprehend the concept of differentiation and choose a formula or technique that works for the given problem. Calculus is used in a wide range of fields. It covers a wide range of topics and is not restricted to a single issue. Thus, with today's level of modernism, the differentiation approach has become essential to all of us.